So what I'm going to do here, I'm going to discuss few design patterns here that we have seen a lot when these enterprises have deployed our solution. And obviously this platform, as you said, is very flexible platform. So there could be many more design patterns. You should be discussing with us if you have a unique requirement, and we should be able to solve your issues or challenges. But I'm going to focus only for the purposes of this discussion. So the first design pattern that we see here, we call it local egress FQDN filtering pattern. So what you see here is that a lot of enterprises, when they come to us with a pain that, hey, I have deployed my application in Azure or in AWS or GCP. Now I need to make sure that when the traffic is going out towards the internet is secure, it is spec'd properly. Because if you're using the native NAT gateway, you can only apply the policies or rules based on the layer 3 or layer 4 constructs. And that is not enough, because that will not pass your audit or your compliance requirement, because you might have PCI, you could have HIPAA or some other application running in these VPCs and VNet. So what we can do, or what we do basically, we can seamlessly, without any disruption, take this NAT gateway out from the picture and then insert the Aviatrix egress FQDN gateways here. So it's a low friction model, as I call it. You can easily do it in minutes, and that will protect all the workload or the applications you have here that are talking to the internet. And this is a platform approach. So we have the controller, we have the Copilot, the Terraform, the automation that we talked about. It's all available in this design pattern. And not only that, this is highly available and scale up and scale out architecture. Because in the diagram, you can see I'm showing only 2 gateways. It does not have to be 2, you can have more. And these gateways, when we deploy them, they are active. So they are taking the active load. In a lot of cases, what I have seen customers, they have deployed hundreds of firewalls in VNets and VPCs. And those firewalls are expensive. And they are working in active standby mode. So basically you're paying for the firewall cost, not only the instance cost, but also the license cost, but you're not getting the full benefit out of it. So this is the model for the local egress FQDN filtering. You can send the traffic out, filter it easily. But there is one challenge with this model, that if you want to have the east-west communication, let's say between your VNet 1 to VNet 2 or VPC 1 to VPC 2, then you have to figure this thing out yourself, right? Maybe you're creating the peering, native peering, which is not efficient, because if you're talking about hundreds of VPCs, then the native peering is not going to work. So what we have seen customers do, they quickly graduate from that model and they follow this MCNA, multi-cloud network architecture model, where we deploy our transit gateways in the transit VNet or transit VPC. That makes it a hub and a spoke model. And now you can see this is your hub, transit gateways, and then spoke gateways, the Aviatrix gateways. And with that model, you not only have the security, the compliance, all those requirements met for the traffic that is going towards internet, but also if they need to talk to each other for the east-west type security, you can leverage this model. I'm not showing here the third-party firewall here, but you can also deploy the Palo Alto, Checkpoint, or Fortinet firewalls here for even further deep packet inspection if there is a requirement like that. And all the benefits that I talked about in the previous slide, the scale out architecture or scale up, active, all the Terraform, the platform approach is also applicable here. So my recommendation to my enterprise customers is to follow this model with the Aviatrix Transit, and then make sure that when you have this architecture in place, it becomes your common standard architecture, not only in one cloud, but if you're thinking about adding another cloud, that can easily extend with one single Terraform or API or the same controller and gateway architecture approach.
And
so
Sheldon, that's effectively the path that you guys took, right?
Yep. Exactly. So that's what Sheldon mentioned. So now Okay, this is great. But what I have seen, another use case comes up a lot, that this traffic is now leaving the VNet or VPCs locally, or in a distributed fashion, if you want to call it. What about if my policy says I don't want to use the IGWs locally on those VPCs? What can we do in that type of situation? So then we have this model for those type of customers where there is a requirement is to send all the VPC or VNet traffic to a common place and then send the traffic out towards the internet. So this is the model that works for those type of customers. What it allows them to do, it allows them to optimize cost even further, because now you're not deploying the Aviatrix gateways in the VPCs or VNet. You have the central location, and then not only that, but you can also apply the security policies in this model here consistently. And you know exactly that this is the place where your traffic is going out towards the internet. So you're attracting all the traffic, and then you're applying the FQDN rules. And when you apply the FQDN rules or the policies, those are not only limited to the external traffic, but if we have internal traffic, we can also inspect that. And it's not only HTTP or HTTPS. We have a wide variety of protocol that we support that you can filter. You have a filtering option for private services like S3 or S3 bucket. You can create the rules that can restrict the traffic going towards those type of services as well. So this is the centralized egress FQDN model, very popular for a lot of customers, depending on your requirement. Now let's move on to the last one, the fourth one. And this is the model that we support with AWS TGW, because we understand that there are customers who have gone to this path of deploying the AWS TGW, and they want to protect the egress traffic going towards internet. So we can seamlessly integrate our solution with your existing AWS TGW type deployment. But remember, you have to know that this is only applicable in AWS. And I know for a fact that a lot of enterprises, they're not going to stay in only one cloud. They will adopt multiple cloud. So this model fails in that type of scenario where you have requirement to support this architecture in multiple clouds. So for that reason, this is not really my recommendation, but if it fits your bill, then obviously you can use it.
Great. So let's go back to the panel discussion here. There's some questions that have come through, so maybe we can talk a little bit about that. One question was about, we've talked about whitelisting. Can we do blacklisting as well? Maybe Shahzad, you want to take that one?
Oh yeah, absolutely. Yeah, and that's perfectly possible. You can have the whitelist option or the blocklist option or blacklist option, as if you want to call it. That is totally fine. We have seen customers who have opted for both approaches. A lot of time they are more lean towards the zero trust model, where they block everything and allow certain URLs, but the other way around is also possible.
Okay. All right, listen, there was another question, maybe Shahzad, about what compute size is required for egress filtering, and maybe Sheldon, we can talk about what you guys have decided to do there as well. Shahzad, is there a requirement specifically there?
No, so this is where our solution shines again, because if you look at other solutions out there, what they have done, they have lifted and shifted their virtual platform into cloud. And when you do that, you're bringing all the baggage with you. So the solution that we have, or the code that we have, is very lightweight. It was written for the cloud. It was born in the cloud. So that's why you can actually deploy this solution even with T2 Micro, which is the smallest size you get in AWS. And then you have the equivalent in Azure as well. So yeah, so this is perfect for all type of customers that are looking for a cost optimized way to start with the egress filtering. And if your requirement grows, let's say if you say, oh, I'm going to have more like 100 MB or even more throughput, you can easily log into the controller and increase the size of your gateway, which is again non-disruptive, and then you can increase or scale up your deployment.
Yeah, Sheldon, you're nodding your head. Is that what you saw?
That's exactly what it is. Yes. Mm-hmm.
Okay, great.